I'm Dr. John Kruse, and today I'm going to be talking about global warming and ADHD. What's the connection? So as usual, I'll start with the take-home message, and the take-home message is 1, the world is getting warmer. 2, hot temperatures do seem to worsen symptoms of ADHD and increase the incidence of ADHD. That's not an extensive body of data, but there is some on that matter. And then 3, to sort of close the loop, as we get more and more ADHD-like in general as a population, that means we have less ability to have sustained attention, that we have a need for greater excitement and something highly stimulating to rouse our abilities or interest in doing or changing anything. And so there's a feedback loop that as it gets warmer, we are probably more passively going to be accepting more global warming, which is going to cause more ADHD. Humans, like all mammals and birds, are endotherms. That means that they regulate their body temperature within a very narrow range, have systems in place physiologically and behaviorally to do that. And that's opposed to animals that are exotherms, which their body temperature largely responds to the environment they're in. So reptiles and amphibians, fishes are generally exotherms. Now, in some ways, that means there's some protective value to being an endotherm. It means we have many more both behavioral and physiological mechanisms within our bodies that help regulate temperature when it gets too hot and when it gets too cold. But in the other way of looking at it, we're actually more vulnerable than those exotherms. We're more vulnerable because the chemical processes necessary for life in our bodies and endotherms are evolutionarily optimized for a very narrow range of temperatures. And outside of that temperature range, very quickly, function begins to be impaired, and eventually that leads to death. Shorthand for thermoregulation, the body gets interoceptive information about what's going on throughout the body. It gets sent up to the insula. I've talked about this in the video on interoception. Information is then passed on to the anterior hypothalamus, and the thermostat, or most of the regulatory networks for tracking temperature and doing something about it, is based in that anterior hypothalamus. And as part of homeostasis, trying to keep our body, all sorts of variables within a fairly narrow range. Temperature, again, is regulated both by behavioral means, where, panting, getting blankets, getting cover if we're too cold, and physiologic, so changes in skin. The little blood vessels and nervous system of the skin can make us better radiators of heat or poorer radiators of heat. At least in America, we talk about body temperature being 98.6, and whether someone has a fever is how much above that. Or in the rest of the world, body temperature is 37 degrees Celsius. But when people say that, it's a somewhat meaningless term, because body temperature normally every day goes through a full 1 degree centigrade approximately variation. So there is not just a diurnal rhythm, which would be a daily rhythm, but a circadian rhythm. So that means there are endogenous internal clocks setting this temperature rhythm. So it's not just a response to being active, physically active and burning calories during the day or moving big muscle groups. Our circadian clocks have temperature actually starts warming up before we wake up, an hour or two, and it starts dropping at the end of the day before we fall asleep, and it helps us make it easier to fall asleep. So again, there's a whole 1 degree fluctuation in temperature. So if you're comparing temperatures or measuring them, it's important to do that at the same time of day. Otherwise, you may get substantially different results looking at different times of day. Measurement of the Earth's temperature is also a complicated process, and there are different ways of weighting water versus land and different land masses. But the consensus is pretty clear that in the last 40 years, there's been a 1 centigrade increase. Again, if you look back or different time frames, you might get slightly different numbers, but that's actually a tremendously rapid rate of change, and it's a significant one, even though 1 degree doesn't sound like a lot. And furthermore, as most people are aware now, that increase in temperature is not evenly distributed. There's greater increase in temperature of the world has been seen at higher altitudes. and less so at some other areas of the world. For decades, the physiologist said outside the ambient temperature had to be about 35 degrees before that was causing stress on the body that we wouldn't be able to keep cooling off. And experiments done just a few years ago showed that, and these were healthy young adults, average age, I think, or very early 20s, is that the temperature is closer to 30.5 degrees, which is 87 for us Americans. So temperatures above that, if those are sustained for a few hours, result in the body heating up internally. It can't continue to get rid of the heat. It's not, we have to wait till 98.6 or 37, our body temperature, before we start running into trouble, but several degrees lower than what we previously thought. And in dry, unhumid conditions, it's actually substantially lower than that 30 degrees. The heat from the ambient temperature is more than our body can continue to get rid of. And if steps aren't taken, either to go into an air-conditioned place or soak yourself in water that evaporates or use a fan, which then might cool you off, it may also dehydrate you faster. So what happens when the temperature gets too hot? So also studies that were done just in the last few years are that even a 1 degree change in the brain, 1 degree Celsius, so 1.8 degrees Fahrenheit, impairs electrical signaling between neurons and can switch the difference between whether a signal was excitatory, becomes inhibitory. So communication between nerve cells is substantially, dramatically affected by just a 1 degree temperature in the brain. And as temperatures go higher, proteins start denaturing, so they unfold, they cease to lose their normal functioning. That can impair whatever processes they were involved in. That can lead to cell damage and death. Even short of cell damage and death, you can start getting inflammation is promoted at higher temperatures. And again, if temperature is too hot or too cold, either extreme, then death will ensue. So what's been specifically known about ADHD and temperature? And a lot of this is not from explicit studies or research, but more general thinking. So some that we have real data on, circadian rhythms in temperatures in people with ADHD are abnormal. Some of this is not unexpected because sleep patterns tend to be abnormal. They tend to be, and this is an overgeneralization, they tend to be phase delayed. People with ADHD tend to fall asleep later at night, wake up later in the morning. But they're not just phase delayed, they also tend to be more irregular, erratic. And even accounting for just that sleep rhythm pattern, temperature rhythms seem to be more, they're not just delayed as well, they're also less robust and more irregular, inconsistent in people with ADHD. There are a few researchers who think that the core neurobiological deficit or problem in ADHD is desynchronization of internal circadian rhythms. And that, again, that would be at least consistent with that observation that temperature rhythms are disrupted in people with ADHD. Second factor is that, and this is a tiny bit of data, and some data goes both ways, that people with ADHD have poorer interoception. They're less aware of what's going on with their bodies, and they therefore take less either behavioral steps or even physiological steps to self-regulate when it's too hot or too cold. Now, the data itself on interoception and ADHD, I've only seen 2 studies, both looking at actually ability to detect, measure, record, or be aware of your heart rate. And one study found that individuals with ADHD didn't have any impairments. The other found that they did. There's also greater rates of obesity among the population with ADHD, at least the last several decades. Didn't seem to be that way 40, 50 years ago. And that makes it harder to lose heat and thermoregulate in some ways. You're more insulated and maybe more protected from extremes of cold. We know again that heat disrupts sleep. If it's too hot, it's harder to sleep. And disrupting sleep itself worsens symptoms of ADHD. And even people without ADHD creates a host of executive function impairments that resemble ADHD. Ambient heat, outside heat, over prolonged periods of time, or when it's at excessive levels, is a stressor to the body, and that causes tension, which could worsen anxiety or depression. And again, there's a feedback loop there, and the anxiety and depression can impair executive function, making people with ADHD have more severe ADHD, or again, reproducing ADHD-like symptoms in people who didn't or were on mild ends of the ADHD spectrum. Other connections between temperature and ADHD are tied to stimulant medications. So stimulants increase heart rate, increase blood pressure, can increase breathing rate, can increase basal metabolism a little bit. All of those are things that would tend to elevate body temperature or at least make it harder to cool down. So there's been a lot of sort of circumstantial evidence and not a lot looking directly at attention in children and ADHD. And 2 studies that just came out in the last week or 2 actually more specifically go into this area. So one study that got a fair amount of media attention was done in the Netherlands and in Spain. They looked at almost 5,000 adolescents, and the measure they were doing was a child behavioral checklist performed by the parent. So it was a rating scale, and they looked at 3 different types of symptoms. So it's many questions. 10 of those questions are pertinent to attention. I think it's 160. That might be off. They also looked at the questions that were pertinent to internalizing disorders, which are the inward focused depression, anxiety type symptoms, and externalizing, which are acting out, breaking rules, breaking laws, violating norms behaviorally. And again, this is a checklist that's well validated. They also tracked for each individual in the study what the temperature was on a daily basis in a fairly narrow, I think 100 by 100 meter area around each individual. And they looked at temperature data for the 2 months preceding this assessment, for the 1 month, and for the 2 weeks preceding, to see if different periods of time that temperatures might be elevated or decreased, depressed, colder, had any effect on these variables. They also did lots of statistical accounting for different confounding. So they looked at age, parental age, income of the family, socioeconomic status, how much exposure to natural environments were in the individual's neighborhood. It was colder in the Netherlands and in Spain, and there were more substantially cold periods. So not just the average was different. There were more hot periods in Spain, and there were more cold periods in the Netherlands. And if they used the 2-month lag period, so looking at the temperature average over that 2 months preceding the assessment, there was a statistically significant incidence of internalizing behavior problems in the Netherlands on colder than normal 2-month intervals, and substantially elevated attention problems in the Spanish group for the periods that were warmer, hotter than normal or expected. The study didn't comment much in the discussion on the fact that even though this was found for the 2-month period, it wasn't seen statistically in the looking at 1 month of temperature data or 2 weeks before the event. In this study, we're not looking at just an acute, really hot day as someone lethargic, less focused, less attentive. We're looking more at, again, ambient temperature around the person. And if it's elevated on average for a prolonged period of time, then that seems to result in measurable changes in attentional abilities as assessed by the mothers. They also did some control to make sure it wasn't just mothers, how they were reporting things or they're influenced by the temperature that was skewing results. So the other study that was published with less media attention that I've seen was a Chinese study, much bigger study. They looked at almost 180,000 kids between the ages of 6 and 18 in 3 different regions of China. The assessment measure was looking at, according to the parent, whether the kid had been diagnosed with ADHD. And what they looked at was, so they had the location where each kid grew up or was living, and they looked at anthropogenic, so man-made sources of heat. So they had a total measure of anthropogenic heat. They had a measure of whether industry in the area was causing substantial increases in heat, whether transportation, so car exhaust is one contributor, buildings, human metabolism. So if you just have so many people packed together, that creates an increase in ambient temperature. All of these separate categories individually, sources of anthropogenic heat, were correlated with substantially higher and about twofold higher rates of ADHD. So kids who grew up where it was hotter had substantially higher rates of ADHD, and they tried to control for a number of other factors: pollution, income, socioeconomic factors. And their conclusion was prolonged exposure to anthropogenic heat is associated with the development of ADHD symptoms in children. Clearly, much more work needs to be done, but these two studies would be mildly suggestive that as it gets hotter, probably increased severity of ADHD symptoms and increased number of people who are going to be diagnosed with ADHD. And again, what's particularly alarming about that is climate change. Most military, most economic experts. This is not about being woke. This is not about being PC. This is simple science and data and very simple projecting how much our world is going to change. Yes, there will be some areas that farming is a little better. There will be some areas that may have a improvement in quality of life. But overall, we know, and we are already seeing many more catastrophic wildfires, floods, storms. That's going to continue. What gets less attention are just heat waves, which kill many more people than any of those. But as it gets hotter, we as a society are less able to sustain the attention. We're more distracted by stimuli of the moment rather than putting our heads down and figuring out what we need to do in the long term and what we need to keep doing on a sustained basis to decrease our global warming. So this, I often talk about feedback loops. This is maybe one of the biggest, most dangerous, and that at the simplistic level, when it's hotter, we're causing more ADHD, and more ADHD makes us less able to combat this global warming. A feedback loop, wherever you break it, it's broken. And there certainly are many people on this planet who are aware of it. And it doesn't matter if extremely short-sighted, foolish, maybe greedy. I don't know what their motivations are. I mean, there's a political movement that wants to deny this is happening or deny that we should do anything about it. All of the economic evaluations show that it will be, the longer we wait to deal with it, the substantially greater the cost will be. And it's cost effective right now to be doing everything we can to prevent it from worsening. That's all I have to say. Stay healthy, stay happy.